So now we're going to start our final review, Calculus 3 review. And so I kind of broke the topics down into 4 groups. So the first one is vectors and space. So this was chapter 11 from our book. Our second topic was vector valued functions. This was chapter 12. And then our third topic was functions of several variables. That was from chapter 13. And our last one was multiple integration. This was chapter 14. So we're going to look and do an overview of all 4 of these under groups. So let's start with vectors and space. So remember, when we have vectors, they're from a point to another point, P and Q. So remember that P is called the initial point, and Q was called the terminal point. And remember that vectors are determined by really 2 things. They're determined by their length or magnitude, and they're determined by a direction. So from here we talked about vectors in component form. So if you have a vector in 2-dimensional space, it would look like AB, or if you had a vector in 3-dimensional space, ABC. And then from here we talked about the magnitude or length of a vector. So let's say we're looking at if V is the vector ABC, then the magnitude or length of V, it's the square root of A squared plus B squared plus C squared. It's really the distance between your initial point and your terminal point. So from here, we talked about vector operations, and there were a couple of vector operations we talked about. Addition, adding up 2 vectors, u plus v. Well, you add them up in their components. So let's say if u is the vector u1, u2, and v is the vector v1, v2, then when I add u and v together, you're going to get u1 plus v1, u2 plus v2. And then, so that's addition. We also had scalar multiplication. So if I take a scalar a times the vector u, this would be a times this vector, and if you just distribute into each slot or each component. So then we discussed how unit vectors are vectors of length 1. And there were some very special unit vectors called standard unit vectors. So these standard unit vectors were the vectors I, j, and k. And then we looked at what it meant for 2 vectors to be parallel. parallel vectors. So we say that non-zero vectors u and v are parallel if there is some scalar c such that u equals c times v. So if one of the vectors is a scalar multiple of the other. So let's look at an example. Are the vectors 3, -4, -1, and 12, -16, 4 parallel? So if I want to answer this question, I need to see, is there, so a scalar c such that 12, -16, 4 equals c. It's 3, -4, -1. So this would be 3c, -4c, -c. And the only way these vectors are equal is if their components or their entries are identical. So 12 has to be equal to 3c, -16 has to equal -4c, and 4 has to equal -c. So if you solve for c in the first one, you get 4. C in the second one, you get 4. But c in this last one, you get -4. So c can't be 4 and -4 at the same time. And so the answer to this question here is no. There is no scalar c. So that means that these vectors are not parallel. So then from here we talked about the dot product of two vectors. So if I take a vector u and a vector v, let's say u is the vector u1, u2, v is the vector v1, v2, then u dot v is defined as u1, v1 plus u2, v2. Now if you look over here on the right hand side, you'll see that this is not a vector. This is a scalar. So the dot product is not a vector. It only produces a scalar. So let's look at an example here. If u equals 1, 3, 5 and v equals 2, 4, 6, find u dot v. So you multiply their corresponding entries and add them up. 1 times 2, 3 times 4, 5 times 6. So you're getting 2, 12, and 30, or 44. And then we also discussed how to find the angle between two vectors. So if I have a vector here, call it u, and a vector here, call it v, and the angle between them, theta. Well, this angle, theta, it's between 0 and pi. 0 would be the vectors point in the same direction. Pi would be that the angles point in opposite directions. And so what's our formula here? Cosine of theta, it's u dot v over the magnitude of u times the magnitude of v. So you can use this formula to find the angle between vectors.